Welcome to the 6th video of the physics lecture series for the National Science and Mathematics Olympiad. In this video, we will discuss Pascal's principle. If you have ever seen a mechanism lifting a car, or one of those hydraulic press videos where they show how the device breaks anything, the question about how this works might have occurred to you as well. The same thought lies behind these two fascinating devices, Pascal's principle. The principle was discovered by Blaise Pascal, a French mathematician and physicist. Pascal did a lot of interesting experiments with fluids. For example, he supposedly inserted a long vertical tube into a barrel filled with water. When he poured water into the vertical tube from a giant ladder, the increase in hydrostatic pressure caused the barrel to burst. Based on his experiments, he invented a lot of useful tools that we still use nowadays, for example the syringe or the previously mentioned hydraulic press. The main idea behind Pascal's principle is that fluids carry pressure everywhere. Take a look at this figure. Here is a closed container of water, but we drilled some holes into its sides. If we apply some pressure from the top, we will see water squirt out of all of the holes equally. You can do the same experiment at home with a balloon or a plastic bottle. Fill it with water, make a couple of holes in it and squeeze it. You will see that the water comes out equally at each hole. This might be very unexpected. Your intuition might suggest that there should be a stronger stream from the lower holes, but that is not the case. Now that we have discussed the main idea behind it, it's time for the formal statement of Pascal's principle. Any change in pressure applied to a confined, incompressible fluid is transmitted equally to every part of the fluid, and the force due to the pressure acts at right angles to the enclosing walls. Here, incompressible means that the liquid cannot be squeezed, so pressure travels through it very efficiently. To see what this law implies, we have to recall the formula for the pressure. P equals F over A, where P is the pressure, F is the force, and A is the area. The formula shows that if we have the same pressure but different area, we will get a different force. Let's see how this works in practice with the example of the hydraulic press. A hydraulic press uses two connected pistons filled with an incompressible fluid. Because pressure is transmitted equally in all directions according to Pascal's principle, a small force applied to the first piston, marked A on the figure, creates a much larger force on the big piston, marked as B. The fluid simply carries the pressure from one side to the other without losing it. By making the second piston's area larger, the same pressure produces a much bigger output force, which is why hydraulic presses can lift cars or crush metal blocks. Take a look at the equations. We can write the pressure at both pistons as the ratio of their respective forces and areas. Making the pressures equal, we can express the force acting on the second piston using the ratio of the areas and the force on the first piston. This ratio of the areas serves as the mechanical advantage. For example, if the big piston is 100 times the size of the small one, then we get 100 times the force. There is a caveat though. Due to the conservation of energy, the small piston must move a much greater distance than the big piston does. So you gain force, but you don't gain free energy. Thank you for your attention and see you in the next video.